Hey children, it's Tuesday night and I'm going to show you how to do problem 3 of your homework step by step. So just a little reminder of what we're practicing this week. We are still practicing solving systems of equations. And when we solve a system of equations, that means we have two or more equations. And we want to know which one individual coordinate point, a pair of x and y values, could we plug in for x and y in these equations that will make both of them true. So I'm looking for an x and y value that'll make the first equation true, but also makes the second equation true. And so yesterday you practiced one way to figure that out, and that was by graphing, but we can also figure it out by using some algebra. So if I take a look here, I know that in this first equation, y is equal to all of this junk on this right-hand side. But if I take a look at the second equation, it also tells me y is equal to this. Okay, so just like I told you before, this is very similar to if I were to say Demaya is the same age as Brianna, and Brianna is the same age as Leslie, then you would know that Demaya and Leslie are also the same age. So since I'm saying y is equal to all of this, and y is also equal to all of this, then I know that these two pieces of junk should be equal to each other. So if I take a look here, I know that these two equation bits should be equal to each other, so I can write negative 5, let me go ahead and get a pen instead. I can write negative 5/3 x plus 1 is equal to negative 1/3 x minus 3. So all I've done is taken this part of the equation and set it equal to this part of the equation. Since I know that both of these equal y, they must equal each other. And so I'm trying to solve this, but of course one of the things I notice is that there's fractions there, and we don't particularly like to work with fractions all the time, especially if we can get rid of them. So what I notice is they both have a denominator of 3, so if I wanted, I could multiply both sides by 3 in order to get rid of that. So I'm going to multiply this side by 3, and I'll do the same thing on the other side. Make sure you add your parentheses so you don't forget to multiply each term. When I'm multiplying this, I'm essentially distributing. Okay. When I distribute this 3 to the negative 5/3, the whole point of multiplying by 3 was to eliminate that denominator, and that's exactly what's going to happen. So it's going to cancel out the 3, and I'm going to be left with negative 5. And then I'm going to do 3 times positive 1, which gives me plus 3. So I have negative 5x plus 3 equals, and I'm going to do the same thing on my right-hand side, 3 times negative 1/3. Again, the 3 will cancel out. That was why we decided to multiply by 3. So I'm going to have negative 1x, or I can write just negative x. That's fine as well. Subtract, and then 3 times 3 gives me 9. So subtract 9. Now at this point, we're just following our properties of equality to try to get x by itself. So I'm going to look at the left-hand side. Can I distribute? No, in fact, I already distributed. If I look in the right, can I distribute? No. Look at the left, can I combine like terms? Remember, like terms are terms that have the exact same variable to the same power. So this one has an x and this one has no variable, so I cannot combine these two. The same thing is happening over here. This term has an x and this term has no x. I cannot combine these two. So the next thing I need to ask myself is, can I move the variables to one side? And the answer is yes, because I have a variable here and I have a variable here, and we know that we want our variable to be on one side by itself in the end, so moving it to one side would help us get closer to our goal. So the question is, which one should I move? Well, negative 5 is less than negative 1, so it'll help me if I move negative 5, because then I won't have to worry about negative variables. So I'm going to do the opposite in order to move negative 5x, which means I'm going to add 5x to both sides. Draw my equal line. So negative 5x plus 5x cancels out. That's exactly why we did that. I bring down my 3 equals. Now negative 1x plus 5x, that means I have 1 negative and 5 positives, gives me 4 positive x's minus 9. Now at this point, this is just a two-step equation that I need to solve for x. So I look on the side where x is, and I ask myself what I can get rid of. I can get rid of the negative 9. How can I get rid of the negative 9? I can add 9 to both sides. So I'm going to add 9 here. I'm going to add 9 here. Bring my equal line. Negative 9 plus 9 cancels out because it equals 0. I bring down my 4x. I bring down my equal sign. And 3 plus 9 is 12. So I'm nearly done solving for my x value. If x is being multiplied by 4, I can undo that by dividing by 4. So I'm going to divide both sides by 4. And I get 3 equals x, or x equals 3, if we want to be proper. Okay. Now this is part of my solution, but this is not my entire solution. Remember, we are looking for a point, a pair of x and y values. So if I'm looking for a pair of x and y values, I want to now take this x value and plug it in to find a y value. Now it's my choice into which equation I want to plug this into. Either negative 5/3 x plus 1 or negative 1/3 x minus 3. Whichever I plug it into, it will give me the same y value. So I'm going to plug it into negative 1/3 x minus 3. So I'm going to write down right beneath here, y equals negative 1/3 times 3, because I'm plugging in that x value, minus 3. Now, just like when we canceled out our fraction, this 3 times 1/3 is also going to cancel out that fraction. And I'm left with y equals negative 1 minus 3. This is an integer problem because I have a negative number and I'm subtracting. So I have y equals negative 1 plus a negative 3 if I keep flip change. So I'm adding negative 1 and negative 3, and I get y equals negative 4. So again, this is not my solution, but this is part of my solution. My final solution would be to write this as a coordinate point, 3, negative 4. This is the solution to this system of inequations. This is the point that satisfies both of these equations simultaneously. It makes both of these equations true. So go ahead and use this as an example to get through problems 1, 2, and 3. And I will see you tomorrow. Goodbye.